So now this one says, write each complex number in rectangular form. So again, when I see this 2 cis 135 degrees, I am always thinking of 2 cosine of 135 degrees plus I sine 135 degrees. And the cis, the I means I sine theta. So that's what's kind of nice about that. It is very immediate, at least for me. Hopefully it will be for you as you do a couple of these. So anyways, so this is really just going to be 2, and I'm thinking of a cosine of 135 degrees. So I always go back to the unit circle here. And when I think of 135 degrees, that's over here. And I know this here is 45 degrees. So that tells me that's 1 square root of 2. That's going to be negative, of course. And then if I'm doing the cosine of that angle, then that's going to be adjacent over hypotenuse. So that'll be negative 1/2 plus I and sine of 135 now, I'm here. That's going to be opposite over hypotenuse. So that's going to be, oh, hang on, square root of 2. I apologize for that. Once I seen that, I was like, whoa, that's wrong. Okay, so 1 over square root of 2. And then the other one is going to be a positive 1 over square root of 2. And then that makes sense because this is all students take calc. So sine is positive in the second quadrant, and that's what we see here. Okay, so anyways, and cosine's negative, and we also see that here. Okay, so now what I'm going to do is we're just going to simplify this. So when I distribute that 2 through, I really get 2 over square root of 2. Don't forget the negative. Plus I 2 over square root of 2. Now again, that's not going to fly for the homework for sure. So I have to rationalize both of these. That means I'm going to multiply both the top and the bottom by square root of 2 and square root of 2 over here. So just all the tops and bottoms by the square root of 2's so that I can get rid of those radicals on the bottom. So then that's going to give us the answer. Negative 2 square root of 2 on the top. And I'm just going to show this step so you don't get mixed up. So it's going to be 4. Oh, not 4. 2. Sorry about that. And then it's going to be plus I 2 root 2 on top here over 2 on the bottom. So now when I simplify this, those cancel, I really get negative square root of 2 plus I square root of 2. So that's our final answer there. So that's essentially how you do it. Just plug those in and go back to your old ways. Hopefully those old ways still exist for you. Okay, now the next problem I want to do is, so this problem says write each problem in trigonometric form. So we're going to take this 4 squared root of 3 plus 4i, and we're going to write it in trigonometric form. So that's the cis theta form that we see here. So now, first things first, we need to find r. So that r is going to be here. And I should say r cis theta when I set this up here. So anyways, so we need to find our r. So we're just going to plug in 4, because 4 squared root of 3 is going to be our x. So that's going to be squared, plus our y squared, which is just 4. It's not the I, be careful. Make sure you don't put that in there. It's just the coefficients in front of the I for the imaginary parts. So anyway, so this is going to be 16 times 3 for the first part, plus 16 equals r squared. Oops. Let me not write this all together here. Okay, so there it is. So now that's going to be 48. So 48 plus 16 is 64. 64 equals r squared. So r equals 8. So r is 8 here. So I'm just going to write that over here. R equals 8. Now we're going to have to find theta. So for me, for the finding theta, I always like to graph it, and the reason why I like to graph it is because it tells me what quadrant I'm in. Now, I'm definitely going to use that tan inverse, so that doesn't change. It's still going to be a tan of theta equals And again, it's going to be the y over x. So that's going to be equals 4 over 4 square root of 3. They're both positive. Okay, so that simplifies. So really I have the tan of theta equals 1 over square root of 3. And I'm just simplifying as I go. So a lot of times I don't know where that might be. Where's tan positive at? It's either positive in the first or third quadrant, but I don't know what quadrant I'm in unless I can visualize this. So now if I'm thinking about 4 root 3 plus 4i, remember this is like my I-axis here, this y is. So that means I'm going to go to the right 4 root 3, and then I'm going to go up 4. So that tells me I'm going to be in this direction. Now I don't have to know the exact place, so don't get me wrong on that. But I will have to understand what quadrant I'm in to begin with, because I could be down here and I won't know until I actually graph it. Now if these were both negative, then I would be down in the third quadrant, which then it would be not the answer I come up with when I do the tan inverse. So it's really good to understand that. So that's why I really push that. So when I do this, I create that triangle, don't I? And then what I get across, because tangent is opposite over adjacent, so that's going to be 1 and square root of 3. And this is my special triangle. That's going to be 2. So then for my theta here, I know my theta right away is 30 degrees because this is my special triangle. So theta equals 30 degrees. So now I can actually write this in trig form. I have everything I need. So this is just going to be 8 cis 30 degrees. There's my answer.